Welcome you to my new video on induction motor. In this video, I will discuss how induction motor starts. When we hear the word how induction motor starts, this video always comes in our mind. In this video, I will discuss in details working principle of induction motor, how induction motor starts, what is synchronous speed. We will derive the expression of synchronous speed, why rotor of an induction motor can't attain the speed of synchronous speed, and also we will discuss why induction motor is called a synchronous machine, why induction motor is called singly excited machine. So this video is going to be very much interesting. So let's start. When three-phase time-displaced current is given to three-phase phase-displaced winding of stator of an induction motor, a rotational magnetic field is developed, which I have already discussed in the previous video. This rotational magnetic field will guard the conductor of stationary rotor. According to Faraday's law, whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. Therefore, when rotating magnetic field guards the stationary rotor conductor, EMF is induced in the rotor conductor. Now, these rotor conductors are connected through either end ring or variable resistance. For squirrel cage motor, it is connected through end ring. For slip ring motor, it is connected to variable resistance. Current will start to flow through this conductor of the rotor. As a result, rotor flux is generated. According to Lenz's law, effect opposes the cause. So this rotor flux is effect. The cause is flux cutting action. That is the relative speed between the stator field and the stationary rotor. So the effect, rotor flux, will try to reduce the cause. That is the relative speed between the rotating magnetic field and the rotor. To decrease the relative speed between the rotor and the stator flux, rotor will start to rotate in the same direction that of magnetic field. Interaction between stator flux and the rotor flux induced a torque in the rotor. This torque is known as electromagnetic torque. In this way, induction motor starts. As rotor has not to give any excitation, that is why induction motor is called excited. The speed of revolution of magnetic field in the stator winding of the motor is called synchronous speed. We calculate it using the formula n is equal to 128 by P. So now we are going to derive this formula. The frequency of generated voltage depends upon the number of field poles and on the speed at which the field poles are rotated. One complete cycle of the voltage is generated in an armature coil when a pair of field poles passes over the coil. Let capital P be the total number of field poles and small p will be the pair of field poles. N is the speed of the field of revolution per minute, that is RPM. Small n is the field pole in revolution per second, that is RPS. F is the frequency of the generated voltage in Hertz. So small n equal to capital N by 60, because small n is equal to RPS and capital N is in RPM, revolution per minute. And small p equal to capital P by 2. Small p is number of pole pairs, capital P is number of pole. In one revolution of the rotor, armature coil is cut by P by 2 north pole and P by 2 south pole. This one cycle is generated in an armature coil when a pair of field pole passes over the coil. So number of cycles generated by one revolution of the rotor will be equal to number of pair of poles, because when one pair of poles is crossed, then one cycle is generated. So P by 2 number of pair of pole is crossed, P by 2 number of cycle is generated. Every 2 pole will give 1 cycle. So capital P by 2, that's mean small p, number of pair of pole equal to number of cycle. Now the cycles, therefore cycles per revolution will be small p, and number of revolution per second will be small n. Now frequency will be, we know that frequency is number of cycles per second, that is number of cycle divided by second. We can write it that number of cycles per revolution and revolution per second. Number of cycles per revolution we have calculated already, that is small p. Revolution per second, that is n, that is in RPS. So F equal to P into n, small p into n. If we replace small p by capital P, we will get F equal to Pn by 120 degree. Now the question is, why rotor never runs at synchronous speed? If the speed of the rotor equal to synchronous speed, no relative motion occurs between the rotating magnetic field of the stator and the conductor of the rotor. Thus, the EMF is not induced on the conductor, and zero current developed on it. Without current, torque is not produced. Because of the above mentioned reason, rotor never rotate at synchronous speed. The speed of the rotor always less than the speed of the rotating magnetic field. That is why induction motor is called asynchronous.